Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Heyawake Sudoku, which is given regions by Senny K. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Kropke dots, where digits in cells joined by a white dot are consecutive, and cells joined by a black dot are in a 1:2 ratio. That is, one digit will be double the other. Not all dots are necessarily given. So, for example, if this were, say, a 6 here, this would have to be 5 or 7 to be consecutive with it because there's a white dot between them. If this were, say, a 2 here, this would have to be 1 or 4 to maintain the 1:2 ratio that's between them because there's a black dot between them. We have Heyawake, where we need to shade some cells so that no two shaded cells are orthogonally adjacent, which means share an edge, and the remaining unshaded cells form one orthogonally connected area. There cannot be a horizontal or vertical line of unshaded cells that goes through two or more region borders. Okay, so we need to shade some cells so that no two shaded cells share an edge, basically. So you cannot have shading here and then shading here. That doesn't work. All the unshaded cells form one orthogonally connected region. And what does it mean to be orthogonally connected? It means you can go from any shaded cell to any other, unshaded cell, You can go from any unshaded cell to any other unshaded cell just by going through edges, all while staying within the unshaded region. So, for example, if we had a shaded cell here and a shaded cell here, that would no longer work because this is unshaded and this unshaded cell cannot get to any other unshaded cell by going through edges, all while staying within the region. And it has to get to all of the unshaded cells that way. So that is what an orthogonally connected area is. And also, there cannot be a horizontal or vertical line of unshaded cells that goes through two or more region borders. So you can go through one, but like, say these were all unshaded. Then you could not have an unshaded cell here because that would go through two borders, which is not allowed to do. And the same thing for horizontal and vertical. Okay, so that's how Heyawake works. It's shading, essentially. We have circles, where digits in circles cannot repeat and must indicate at least one, but may indicate both of the following: the number of shaded cells in their region, and the number of unshaded cells in all up to 9 surrounding cells. Interesting. Huh. Okay. So the circles, again, you have to have, there are no repeats in circles. So you have to have the digits 1 through 9 in all the circles. And they indicate one or possibly both, but that you only need one of the following. If it's a shaded cell, the number of shaded cells in their region. In their region. Huh. The number of shaded cells in their region. So I assume that means the boxes, right? Yeah, because it's given regions, and these are the regions. Okay. Right. So the number of shaded cells in their region, or the number of unshaded cells in all 9 surrounding cells. So this matches essentially, it will be the number of shaded cells in the region and the number of unshaded cells in this region specifically. But these are going to be different, right? Because they can only match the shaded cells in the region, or in this case, it would have to be the up to 6 number of unshaded cells in the surrounding cells. And finally, shaded cells can only contain the digits 1, 2, 3, or 4. Only digits 1, 2, 3, 4 can appear in shaded cells. Interesting. And so okay, let's say this was shaded this way in this middle box. Then this could count either the number of shaded cells in the region, which is 3. So this could be 3, or it's the number of unshaded cells in the up to 9 surrounding cells, which would be 6 in this case. It actually shouldn't be surrounding cells, but it should be in the 3x3 box centered around the circle, I should say. That would make more sense. Because otherwise it wouldn't be up to 9. If it's just surrounding cells, it's just 8, right? So, yeah, and you can't have 9 shaded cells in a region, because then they would be sharing an edge. And that's not allowed. And since you have to have the digits 1 through 9, it has to be the 3x3 box that's centered on the circle. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, I'm not sure quite how to do this. How many shaded cells can you have in a region? I think 3 is the most. Oh, maybe you could have 4. Right? Yeah, you could have 4. You cannot have... I mean, technically you could have 5 also. That's possible. That only is... 5 only works, though, in the center box. In, like, boxes like here, if you close off this center one, this cell is not orthogonally connected to the rest of the unshaded cells. So, number of shaded cells in a region that's not the center box is 4 at most. And this is up to the 3x3 box that's centered on the circle can only have 4 unshaded cells. So this is 1 through 4, this is 1 through 4, this is 1 through 4, and this is 1 through 4. Which means the remaining digits must be 5 through 9. Because we have the digits 1 through 4 all in a row. This can't... shaded cell... This has to be the number of unshaded cells. It must be 5 or 6. Same here. This is 5 or 6. Because the number of shaded cells can only be 4 at most. This can't be 5 because it's next to a black Kropke dot. So this must be 6 and 3. That makes this not 5, 6. It can't be 6 here. Can't be 5, 7, or 9. Because again, 5, 7, and 9 cannot be next to a black Kropke dot because it's a 1 to 2 ratio. 5, 7, 9 halved gives you 2.5, 3.5, 4.5. And double 5, 7, 9, you get 10, 14, or 18, none of which are digits. So this must be 8, which makes this 4. This 6 eliminates 6 here, so that's 5. So this has to be 7 or 9 here. And 9 cannot be consecutive with 2 unique digits, so this must be 7, which forces this to be 9 here. So this is 6, 8 as a pair. 6 and 8 is a 1 to 2 ratio with 3 or 4. 5 is consecutive with 4 and 6, which makes this 3 and 7 to be consecutive with those. 4 and 6 is going to be in a 1 to 2 ratio. This 4, 6 pair eliminates 4 and 6 in the rest of the column. This can't be 4. This can't be 4. 4 eliminates 4 here. So this must be 4 here, which means these are all you could have 4 shaded cells or 4 unshaded cells. We're not sure which. 5, 6, 7, 8, and 9 can only be unshaded. So these are all unshaded, which we'll mark as green. 6 has to be with 3. So one of these is 3, which eliminates 3 in the rest of the column. So this becomes a 1, 2 pair, which forces this to be 3 here. That's 3 in the corner. We have a 1, 2 pair now in column 9. So that eliminates 1 and 2 in the rest of the column. And 4 then has to be in a 1 to 2 ratio with 8, because it can't be with 2 anymore. So this is 3, 8 as a pair. That forces this to be 7, 9, 7, 9. 7, 9 are both unshaded. So blue is the shading. Remaining digits of column 5. We have 1, 2, 5, 7. Okay. 3 and 7 are consecutive with 4 and 6 or 2 and 8. Remaining digits of box 6 are 1, 2, 8, 9. 9 cannot be either of these. 8 can't be either of these because of the 6, 8 pair in the row. So this is 1, 2 as a pair. So there's 9 unshaded cells in the surrounding 3 by 3 box. 6 has 6 unshaded cells in the 3 by 3 box centered on it. 7 has 7. 5. We have, this is all unshaded. So this must be shaded here. So this is 1, 2 as a pair, which eliminates 1 and 2 in the rest of the box. This is 8 and 9. So it cannot be shaded. It cannot be shaded. This can't be shaded because it shares an edge with the shaded cell. So this is unshaded. One of these has to be shaded. This has to be 3 or 4. These are all consecutive. Remaining digits in column 7 are 1 through 7. This cannot be 1 here, because that would force 2 to be here, and that would eliminate all possibilities for this cell. So no 1 here, no 1 here. This can't be 6. 3 eliminates 3 here. These... Okay. So this must have 2 shaded cells here. One of them has to be here. Oh, these are both shaded. Sorry, unshaded. Therefore, this must not be unshaded. So this has to be shaded. This is shaded, and we have 7 unshaded cells in the 3 by 3 box surrounding it. So this is unshaded here. This is shaded, so it can only be 1 through 4. 1 through 4 here. This can't be 4 here. No 1 or 2 allowed here. So this can't be 1 because that would eliminate all possibilities for that cell. Same this. This can't be 3 or 4 either. If this cannot be 2. If this is 2, the problem is that would have to be 1 or 3 here. 2 and 1 would eliminate all possibilities for that cell, and 3 can't be here, so therefore this can't be 2. So this has to be 5, 6, or 7. If it's 5, it has to be with 6. If it's 6, it has to be 5 or 7. If it's 7, it could be 6 or 8. So we don't know what that is. This cannot be 2 here because that would force 3 to be here because it can't be 2 and 1. If this is 2, you cannot have 1 here, so it could be 3 here. If it's 3, cannot be 4 here, so that's 2. If it's 5 here, it can't be 5 because 4 and 6 are eliminated from the row. 7 can be with 8. So this is either 2, 3, or it's 7, 8 here. So this contains a 3 or 8, and this is 3 or 8, which eliminates 3 and 8 in the rest of the box. So this cannot be 3, this cannot be 8, which means to be consecutive here, you can't have 2, because 2 would have to force a 3 there because it can't be 1. Where is 1 in column 1? It has to, column 7, it has to be here. So that's 1, which makes this 2. That eliminates 2 from being here. So the 3 has to be next to a 4, whichever one it is, because it can't be next to 2 there. 2 can't be here. Since 2 can't be here, this can't be 3. Where is 3 in column 7 then? 3 has to be here. And 3 has to be with either 4 or 2. So this is guaranteed to be 3. This is 3 or 8 here. This is 3 or 8 here. 9 is one of these two. We have a 3-7 pair in column 8, which eliminates 3 and 7 in the rest of the column. This can't be 3. It's 8, which makes this 7 to be consecutive. No 7 here. No 7 here. This has to then be 2 and 3 to be consecutive because there's no other place for the 2. 8 eliminates 8 here, so that's 3, which is in a 1-to-2 ratio with 6, so that's 4 and 8 there. 6 is consecutive with 7 out of 3 or 7. That's 3. So this must be 7's consecutive with 6. This can't be 6 here. It's 4 and 5, which eliminates 4 and 5 in the rest of the column. No 5 here. It's 6, which cannot be consecutive with 7 or 8. So this is 5. This can't be 6. It cannot be 8. It's 4. 2 and 3 is a pair. Eliminates 2 and 3 in the rest of the box. So this is 1, which makes that 2. That leaves this as a 7-9 pair here. And this 7 eliminates 7 here, so that's 9, which makes this 7, which makes this 9, which makes this 1. So 7, 8, 9, 5, 6, 7, 8, 9 are all unshaded. 6, 7 is unshaded. That's fine. You could have 1 shaded here. Could have 1, 2 shaded here. This, okay, in the surrounding 3x3 area, the number of unshaded cells is 3. So this cannot, this means there's only 1 shaded cell in this region. This could be 2, if this is shaded and shaded there. That's possible, because this would be unshaded too. Can this ever have 4 shaded cells? The answer now is no, because the 4 scenario has to be these 4. right? These 4 doesn't work because then this is not orthogonally connected to the rest of the unshaded cells. So this must be 4 unshaded cells in the 3x3 box that's centered around that circle. So these are all unshaded. This has to be unshaded. This is unshaded because these are shaded. This is going through one boundary here, cannot go through 2, so this is blue. This is green because it shares an edge with a blue cell. So this cannot be 2 or 4, it's 1 or 3. This is going through one boundary here, so this must be blue, which makes these both green. Since this is 3 greens here, this doesn't count the number of unshaded cells, it counts the number of shaded cells in the region. So one of these is blue. This is blue here. One of these must be blue here. We're not sure which. This could be all green. We don't know. Hmm. One of these has to be blue. Because the problem is if they're both green, that would force 2 blues here, and they can't share an edge. So that doesn't work. We don't have anything here. Same problem here, right? If they're all green, you would have to have all blue here, and they would all be sharing an edge. So you need some combination of 2 blues and 3, right? 2 on one side and 1 on the other side to make sure that they don't go through 2 regions. One of these is obviously blue. We don't know which. Let's just do remaining digits. We have in row 9 1, 3, 5, and 9. Obviously no 3 here because of 3 in the box. In row 1, we have 2, 7, 8, 9. No 8s here because of 8 in the box. 2, 7, 9, 2, 7, 8, 9, 2, 7, 8, 9. This has 8 cells in the surrounding 3x3 box that are unshaded because you can't have 8 shaded cells. So this must have 1 here, which means this is blue. This has to be blue both here because the rest of this is all unshaded. And this has to be blue here to block the 2 and 2 here. So this is blue here, this is green. This cannot be 5 or 7 then, because 1 and 2 can only be in the shaded. This is 1, 2, or 4. 1, 2, or 4 there to be shaded. So this goes through whatever. That's fine. This has 1 shaded cell in the region. So this is 7, 6. One of these is shaded. We have 2 shaded cells in this region. This has 2 shaded cells, or this is unshaded cells going through with 1 region, or 1 region border. So this cannot be shaded. It's unshaded, which means these are unshaded. This is shaded, so these are unshaded. This has to be a 2. which eliminates 2 in the rest of the row. This is 7, 9 as a pair, which eliminates 7, 9 in the rest of the row, so this is 8. That eliminates 2 here and 2 here. So one of these is a 4. This goes through 2 levels, so this must be shaded, which means this is unshaded. We have only one shaded cell in the region because this cannot be one unshaded cell here. So this is unshaded. This is unshaded. We have this goes through 2. Cannot be unshaded here, so this is shaded, which makes this unshaded here. This goes through 1 border, cannot go through 2, so this is shaded. We have 2 shaded cells in the region, so this is unshaded there. You cannot have 3... You could have 3 unshaded cells here. One of these must be blue. Because if you're not... So say both of these are green, you'd have to have 2 blues there, which is impossible. So one of these is blue. And it must be 1 or 2, which means this has to have a 4 here. Which means this can't be 4, that's 5, this is 4. Oh, so this is shaded, so this has to be 4. Therefore, this cannot be 1, 2, or 5 because we have a shaded cell here which must contain 1 or 2. So that eliminates 1, 2, and 4 in the rest of the row. This can't be 5. It's 7, which eliminates 7 in the rest of the column. One of these is 1 or 2. This cannot be 1, 2, 4. So this is 8 or 9 here. Remaining digits in column 3. We have 5 through 9. And this cannot be 8 or 9. No 8 here. No 9 here. This is 1 or 2 with 8 or 9. So 9 has to be one of these 2 digits here because it can't be here. Remaining digits in box 8. Let's do row 8. We have 2, 5, 6, 7, 8. No 9. 2, 5, 6, 7, 8. No 7 here because of 7 in the column. No 7 here or 7 here because of 7 in the box. No 6 here or 6 here because of 6 in the box. So we know 6 is one of those. 7 is one of those. 3 cannot be here. 3 is one of these 2. But it could be one of those, though, too. 9 is one of these 2, so this cannot be 9 here. We know one of these has to be blue to stop the unshaded cells here. So then that eliminates, that has to be 1, 2, or 3. Cannot be 2 or 3, so this is 1 here, which means this can't be 1, that's 2, which makes this 3 and 2 there. So there's no 2 here, no 2 here. This is 1, 5 as a pair, which eliminates 1, 5 in the rest of the box. So that leaves the remaining digits as 2, 6, 7, 8. No 6 or 7 here, no 6 or 7 here. It's 2, 6 or 7. I don't know how to remove 8. Therefore, it's 2, 8 as a pair in box 5, which eliminates 2, 8 in the rest of the box. 2, 8 also eliminates 8, 2, 8, 8 in the rest of the row. So this is 9, that's 8. Okay. Remaining digits of row 3. We have 5, 6, 7, 9. No 7, 9 pair because of 7, 9 in the box. So this is 5, 6 pair, which eliminates 5 and 6 in the rest of the row. So this must be 1, 7, and 9. That eliminates 1, 7, 9 in the rest of the box. So this can't be 7. This is 4, 5, and 6. 4 cannot be here. Where is 4 in this box? It has to be here. So that's 4. That leaves 1, 3 as a pair remaining in row 2. Okay. We know we have a 1 there. So that blocks the unshaded cells here and then here. Can you have 3? I mean, you could if this is shaded. Or you could just have... Can you ever have 4 unshaded cells? So this must match both. But the problem is... Yeah, the problem is we don't know where they are. Well, this can't be shaded, so this is unshaded. It's 5 or 6. Oh, well... If this were shaded, this would be all unshaded. Because you only have 3 shaded. We have 1 here. We have 1 here. And there's 3 unshaded cells here. But the problem with this is shaded is this would be 3 unshaded. This would be unshaded. This would have to be shaded to match the 3 shaded cells and to block the Heyawake unshaded set. So, and this would not be orthogonally connected. So this cannot be shaded. It's unshaded. So 3, again, matches the number of unshaded cells or the number of shaded cells. Either way, it matches both. So this is 3 there. That means... Okay. 8 eliminates 8 here. Whoops. 8 here and 8 here. Remaining digits in row 6 are 1, 3, 4, and 5. No 3 or 4 here. This is 1, 5 as a pair, which eliminates 1, 5 in the rest of the row. No 1, 5 here. No 1, 5 here. This is 3 and 4. 4 has to be one of these, so this cannot be 4 here. It's 3, which makes this 4. Which makes that 1, which makes that 3. So no 3 here. Where... 1 eliminates 1 here, so this is 5, which makes this 1, which makes that 5. Remaining digits in row 4 are 2 and 9. Okay. 7 eliminates 7 here. 5 eliminates 5 here, so it's 6 and 5. We need a 6 in column. 6 eliminates 6 here, so this is 8, which makes this 6. 5 eliminates 5 here, and this can't be 6 either. It's 7, 8. So 8 cannot be here. 6 can't be here. Where is 6 in box 7? It has to be here. So that's 6. One of these is a 7. We have a 1, 2, 9 triplet in column 2, which eliminates 1, 2, 9 in the rest of the column. This can't be 1, it's 5, which eliminates 5 from here. This is 1, 9 as a pair, which eliminates 1, 9 in the rest of the box. So this can't be 1, it's 2 and 4, which eliminates 2 and 4 in the rest of the row. So this is 1, 9 here. That means this can't be 2 here. It's 5, 8 as a pair, which eliminates 5, 8 in the rest of the row. So this is 7. No 5 or 7 here. It's 2, which makes this 9, which makes that 2. 9 eliminates 9 here, so it's 1 and 9 here. 1 and 9 eliminate 1 and 9 here, so it's 7, which makes this 9, which makes that 1. So this is then shaded, and this is shaded, and these are unshaded. Okay. 6 is in a 1 to 2 ratio with 3, so this is 3, that's 4, which makes this 2 and 4 there. 2 eliminates 2 here, so it's 8 and 2. 3 eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 9 and 1. 8 eliminates 8 here, so it's 5 and 8. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 7 and 6. 7 eliminates 7 here, so we have a 9 and a 7, and we forgot the 8 there. Yeah, fairly straightforward. The rule sets were kind of interesting. Yeah, definitely Heyawake is basically, it's less restrictive than a lot of like other shading puzzles, like yin yang, right? So you could do a wider variety of puzzles, but you can't rely so much on certain things to be able to have like a minimum of rules there, right? So anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.